happening to his chest?
Oh, what is that? Oh!
I'm Jake, and you might be wondering how I got here. Well, before my crew and myself were being stalked in space by a xenomorph, I had two loves in my life, science and movies. So I decided to put myself in one of my favorite films, Alien, to find out if you could survive it. Could you survive being splattered by acid blood, a parasite gestating in your body, or firing a flamethrower in a spaceship? Could you survive Alien? Most people take comfort in the fact that a parasitic alien bursting out of your chest is just movie make-believe. However, something like that exists on Earth. Jewel wasps lay their eggs on cockroaches, and once the eggs hatch, they eat their way into the cockroach's abdomen, and after eating its internal organs, cocoons inside, eventually completing its metamorphosis and emerging from the cockroach's abdomen. Or there is the human botfly, and just a warning, this footage is kind of gross. Some botflies lay their eggs on the abdomen of mosquitoes. Then a mosquito bites you and the eggs enter through the tiny hole left behind. They gestate under your skin until they become larvae and burrow back out. All pretty nasty, but not as nasty as this particular space parasite, because it literally bursts out of your stomach, horribly killing you. Oh, and it also has acid for blood, which I learned the hard way. And speaking of acid for blood, let's head into the lab. So is there an acid in real life that acts like what we see in Alien? Well, it turns out there is. It's a super acid called fluoroantimonic, and it is so corrosive that it can't be stored in glass. It literally breaks pH meters, and the fumes from it are toxic. So labs like this one logically won't handle it. But we found the next best thing called aqua regia. It is an acid that is comprised of nitric and hydrochloric acid. It's generally referred to as royal water because of its unique ability to break down noble metals, things like gold or platinum. And we're gonna be testing it on a few things that we see acid on in the film. Specifically, fabric, metal, flesh, muscle, and bone. And it should be pretty destructive. First up, fabric. In the movie, it eats through the fabric almost instantly, so... nothing. Next up, a metal plate, which melted in less than 10 seconds in the movie. And it didn't erode the metal. In fact, it just caused oxidization, which is when an element loses electrons when combined with oxygen, provided by the acid in our experiment. You might know oxidization as rust. Destructive alien acid blood is looking like cinematic wishful thinking. But what about flesh and bone? You know, what humans are made of. In the movie, the characters survive their encounter as long as they... Oh no. The acid instantly starts to dissolve the flesh and bone. What we're witnessing is hydrolysis. Hydrogen ions in acid are really attractive to other atoms. As parts of the material break off to bind with the acid, it dissolves that material. But there's actually something more deadly than the acid. As the acid dissolves the flesh, it releases a vapor comprised of nasty toxins, including nitric oxide, which you can see right here. Breathing those fumes causes nearly instant respiratory tract damage, as the chlorine and nitric oxide combine with the moisture in your lungs, forming an acid inside your lungs. Not pretty and potentially lethal. Oh, even though the acid doesn't destroy the fabric, that fabric has absorbed the acid, which means if you're wearing it, then it will get onto you and... Ugh. In the real world, spaceships are made from a lot of aluminum, which got me thinking, what would the acid do to aluminum? The results are impressive and terrifying. The acid completely ate away the aluminum. So, yeah, not good. I hope I didn't drop any on the ship. So, not only would the acid be devastating, but the fumes would be deadly. Oh, and also, check out this cool thing I got. It tracks micro changes in air density and then alerts me if there's an alien nearby. Okay, I gotta go get it before it gets everyone else. Oh, why are you so scary and lifelike?
Talking to yourself again, Jake?
Oh, Austin, we gotta get this thing off the ship.
We have to bring it back home with us to Earth. Imagine all the things that we can learn from it. All the possibilities.
Austin, it's getting closer. Oh! Oh no, this isn't good. I got you, buddy. All right, should be okay. Okay, this is bad. I should probably call Earth and ask for help.
But is it worth it?
What do you mean?
Well, we are limited to radio communication, which is pretty good, since radio signals travel at 299,792,458 meters per second, the speed of light. So, if we were staying near Jupiter, it would take only 48 minutes for our message to be received, and then another 48 minutes for us to get a response. But we are currently located near the moon LV-852/2, which is 39 light years away from Earth.
And 1 light year is equal to the distance something would travel at the speed of light in a year, so there's no reason for me to call for help, because in space, nobody can hear you scream for 39 years. But you're a tech-savvy guy, or I guess a robot, so do you know of any way where we can communicate quickly over interstellar distances?
There are a few theories. Tachyon particles, quantum entanglement, and wormholes. But again, these are just theories.
Yes, but they're awesome, so I'm going to explain them. Tachyons are hypothetical particles that travel faster than light, and if they did exist, you could theoretically have communications across vast distances. The issue, however, is that you would need an infinite amount of energy to slow those particles down so you could actually get the message, which we currently don't have the technology to do. Then we get to quantum entanglement. In quantum physics, entangled particles remain connected so that the actions performed on one affect the other, even when separated across large spaces. One issue, however, is that it seems to rely on the indeterminate state of the particle, meaning it's hard to determine the position of that particle, which would make it difficult to send specific messages. And lastly, we get to wormholes, or Einstein-Rosen bridges, as they are technically called. We still aren't sure if they exist, but if they did, you could easily send a message or object in one end, and it would come out the other. It's basically a shortcut through space. And speaking of holes, Austin's head is just in a hole in the table. Now, most modern movies would use computer effects, digital effects to sell this, but in Alien, they did this. They put the actor underneath the table on some apple boxes with his head through a hole, and actually, it's through 2 half circles. The reason they do this is so they can get a tighter fit around the neck to sell the effect that there's a head sitting on a table, coupled with, pardon me, Austin, I'm sorry, some prosthetics to look like flesh, wires, and goo. You feeling good?
Absolutely not.
Great, let's put it back. All right, buddy, I gotta go back and do my scenes. Good luck.
Wait, why are you leaving? I can't move my arms.
He should be fine. Oh, now it looks like the alien's in the cockpit. Let's get it. Wait, there's nothing in here. Is this thing busted? Oh no. How did this hole get here? Hold on to something, we're gonna get sucked out.
Not.
Oh, Neil deGrasse Tyson, you're alive. This is fantastic, but continue, what were you saying?
Well, if you're right at the hole, yeah, it's a little bit of push on you from the air, and you'll fall out, all right? But if you're anywhere else, you'll just feel this air go around you. Say, what's that breeze? Oh, the cabin is depressurizing. That's all that's gonna happen. But there seems to be a trope in all movies where people fly out the airplane window, fly out the spaceship. No, you'll just stand there, you'll feel a little breezy for a few seconds, and then that's it, until it equilibrates. But what will happen to you if you fall out into the vacuum of space? You are now in 0 atmospheric pressure. That's not good for the dissolved gases in your bloodstream. It'll take a little while, but ultimately, gases that are in your bloodstream, previously in equilibrium with an atmospheric pressure, will begin to bubble up and come out of your bloodstream. And you'll start getting gas bubbles in your body. That is not good, okay? But that's not the first thing you'll notice. The first thing you'll notice is that there's no air, okay? So you will die from suffocation before anything else bad will happen to you.
That is great information, thank you very much, you're a gem. Also, stay safe, the alien's still here. And speaking of, I think I have an idea of how we can take care of this alien once and for all. might not have guns, but we do have flamethrowers. Let's light this up.
Jake, no, this is a terrible idea.
Amy, first, I am so happy that you're alive, but second, fire kills everything.
I know that, but it's also going to kill you. There's so much oxygen in here under pressure. No! Sorry, Jake. But you know, why would anyone think a flamethrower in space is a good idea? I mean, you're gonna burn yourself to death on the flames, and if you don't, you're gonna use up all of your available oxygen and asphyxiate. Either way, it's a really bad day. Let's just show you what that looks like. To safely demonstrate the devastating effects, we sealed the end of a flamethrower into an airtight container. Combustion requires 3 things: fuel, oxygen, and an ignition source. In Alien and in our experiment, the flamethrower provides both the spark and the fuel, and the air in the container provides the oxygen. Within seconds, the flame consumes all the oxygen in the room, which is good because without oxygen, the flame will extinguish. But it also means that even if you survive the flames, you'll suffocate from a lack of oxygen. To say nothing for the horrific burns across your body. One other bit of good news: we would assume future spacecraft or bases, like modern spaceships, are pressurized with breathable air, which is only about 21% oxygen. The balance is usually non-flammable nitrogen, so while you'd still be horribly burned by the fire, it would extinguish pretty quickly, or at least spread slowly enough to be manageable. What's crazy is that the original Apollo-era missions used pure oxygen. It was a simple and light system, and at a low enough pressure that a fire wouldn't be fatal. Except when that fire was on the launch pad with the cabin under high pressure. When a fire sparked during a test of the Apollo 1 spacecraft in 1967, the crew sadly was killed. It was too late to retrofit a dual gas system into Apollo and still get to the moon by the end of the decade, so NASA kept pure oxygen in flight, but it did change the high-pressure launch atmosphere to an oxygen-nitrogen mixture. But in this case, Jake either burned to death or suffocated. It looks like I'm the only survivor on this ship. At least the only human survivor. But I think I know how to get rid of this thing. This parasite is clearly taking on some of the traits of its host, and since it's living in this environment, we can assume that it's a carbon-based life form. So we don't need to use a flamethrower or blow it up. We just need to cut the oxygen. It's that simple. Sorry, guys. There's only room for one in this escape hatch, and as always, thanks for watching. The alien should be dead, but you know, there's only one way to be sure.
This season on Could You Survive the Movies? Could you survive fire in the hole? Welcome to the party, pal! You think he's okay?
We have nothing to fear.
Oh, well, that's great.
Or do we? God, I love TV.
And, as always,
Thanks for watching.
Oh, that wasn't too bad.